For decades, astronomers believed that the Milky Way and Andromeda galaxies were on an unavoidable collision course. Andromeda, the closest large galaxy to the Milky Way, is approaching at a speed of 110 kilometers per second, 68 miles per second. In the early 20th century, astronomer Vesto Slipher discovered that Andromeda's light was blue-shifted, indicating its movement toward us. Based on this, scientists long predicted that in roughly 5 billion years, the two spiral galaxies would collide and merge, forming a massive elliptical galaxy, sometimes called Milkomeda. This cosmic event would drastically reshape both galaxies, triggering waves of new star formation. In this video, we'll delve into recent findings that challenge this long-standing theory, explore their significance, and discuss what they reveal about our galaxy's future. The original prediction: a Milky Way-Andromeda collision. For much of the 20th century, astronomers accepted the Milky Way-Andromeda collision as an inevitable event. Observations of Andromeda's motion, along with gravitational modeling, suggested that the galaxies would eventually merge in a colossal cosmic dance. However, despite the dramatic nature of this event, individual stars would likely not collide due to the vast distances between them. Instead, gravitational forces would reshape the galaxies, transforming their spiral structures into a single, larger elliptical galaxy. This merger could push our solar system to the outer edges of the newly formed galaxy, completely altering its position in the Milky Way. While such a collision wouldn't pose a direct threat to most star systems, it would significantly change the galaxy's overall structure. The idea of this impending galactic merger has long fascinated astronomers and the public alike, raising questions about its potential impact on planetary systems like our own. Could gravitational disruptions affect planetary orbits? Might such changes threaten the stability of existing star systems? Though largely speculative, these concerns highlight the profound scale of such an event. A new perspective. Is the collision still certain? Recent studies have cast doubt on the inevitability of a direct Milky Way-Andromeda collision. A research team led by astronomer Till Soala from the University of Helsinki used data from the Gaia and Hubble space telescopes to create new simulations of our local group, a cluster of galaxies that includes the Milky Way, Andromeda, the Triangulum Galaxy, and the Large Magellanic Cloud. Their findings suggest that gravitational influences from these smaller galaxies could significantly alter the trajectories of the Milky Way and Andromeda, introducing a level of uncertainty that had not been accounted for in previous models. The new simulations indicate that there is now a 50% chance that the Milky Way and Andromeda may avoid a direct collision. Instead, they might pass close to each other, resulting in a near-miss rather than a full-scale merger. This contrasts sharply with earlier models that predicted an inevitable collision within 5 billion years. The gravitational pull of other nearby galaxies, such as Triangulum, may be strong enough to divert the Milky Way and Andromeda from their previously expected collision course. This uncertainty stems from the challenges of measuring the precise masses, positions, and velocities of the galaxies involved. Even with advanced observational data, significant margins of error remain, leaving multiple possible outcomes. While some models still suggest a future merger, others propose that the galaxies' paths may diverge due to complex gravitational interactions. What if the collision never happens? Even if the Milky Way and Andromeda don't fully merge, a close encounter could still cause major disruptions. Their gravitational interactions could send streams of gas and stars into intergalactic space, forming long, luminous tidal tails stretching between the galaxies. Such interactions could also trigger new bursts of star formation, though on a smaller scale than a full merger would have produced. But even if a direct collision is avoided, the story of our galaxy's evolution is far from over. The local group will continue to evolve over the next tens of billions of years. The Triangulum Galaxy and the Large Magellanic Cloud are also key players in this cosmic dance. These smaller galaxies may eventually merge with either the Milky Way or Andromeda, or even form a larger multi-galaxy merger. This process, known as galactic cannibalism, is a fundamental aspect of cosmic evolution. Larger galaxies have long absorbed smaller ones, growing in size and complexity over time. The Milky Way itself has undergone multiple mergers with dwarf galaxies throughout its history, a process that will continue far into the future. The role of dark matter and the uncertainty of galactic fate. A major factor influencing these interactions is dark matter, the invisible substance that acts as the gravitational scaffolding of the universe. Dark matter holds galaxies together and guides their movements, playing a crucial role in galactic mergers and interactions. However, its precise effects remain a mystery, adding another layer of unpredictability to our understanding of galactic evolution. Despite our technological advancements, we still cannot say with absolute certainty how these events will unfold. The dynamics of galaxy interactions, influenced by dark matter and other factors, are incredibly complex and introduce a level of unpredictability that keeps astronomers constantly refining their models. The future of the Milky Way. So, what does all of this mean for our galaxy's future? The answer is still being written. With upcoming data from missions like Gaia, astronomers will continue refining their models to offer more precise predictions about galactic movements and interactions. Each new discovery brings us closer to understanding the grand narrative of galactic evolution. As we explore the mysteries of dark matter, galactic cannibalism, and the future of the Milky Way, we are uncovering new insights into the past and future of the universe. The fate of our galaxy is still uncertain, but with ongoing research, we move closer to unraveling its ultimate destiny. Thank you for watching. As we gather more data and improve our models, we edge closer to revealing the true future of the Milky Way and its place in the ever-changing cosmos. This version enhances readability, refines the flow of ideas, and improves clarity while keeping all the key information intact. Let me know if you'd like any modifications. Smiling face with smiling eyes.